A vintage model traction engine restoration, part 14, fixing the crankshaft driven water pump, by fitting the water pipe to it so it doesn't leak. And in this episode I will also fix the dribbling draincock. Draincocks of this type are okay, except they usually leak. The only ones that I know that don't leak are some that are sold by a friend of mine under the name of 21st Century Steam. So why don't I use one of those? Well, it would be brand new and it will look completely wrong. I found this one in my box of old draincocks. I always save them, even if they're broken. And here you see the old draincock fitted to the pipe and it looks like it's always been there. This is my surface plate. It's a big lump of cast iron and it's flat. And on the surface plate is a piece of 400 grit wet-to-dry sandpaper. And to the viewer who wrote in and told me to stop calling it sandpaper, the comment was quite aggressive in its own pathetic way. He went on to tell me that I should call it silicon carbide paper. So just for you, sandpaper man, I'm cleaning up the pump body and the flange using some wet-to-dry sandpaper on my surface plate. Why am I using a surface plate? Because it's flat. For quite a few clean-up jobs, my workbench is flat enough, but when I want the parts to be more accurate, I always use my surface plate. Just in case you're wondering, this is not a photograph of a bird dropping. And here it is, joined by the other half of the two-pack mix, which is known as JB Weld. This is the 24-hour version. It's very strong indeed. What I'm doing here is looking in my box of 6BA bolts for a couple of suitable 6BA bolts. And here they are. I had to shorten them a bit, but they'll do the job perfectly. I'm using JB Weld a bit like a super gasket material. The problem with this water pump is that the flange was only held to the main block using two 6BA bolts and they're just not strong enough. That's why I've flattened both the flange and the block itself using the wet-to-dry sandpaper. You will notice that I'm applying this JB Weld very carefully. When the flange is screwed in place using the two 6BA bolts, the JB Weld will be squashed by the flange. And the last thing I want to do is to fill up the hole in the middle. So here, at the end of this sequence, I'm smoothing out the JB Weld that I've applied, making it a very thin layer. Once I bolted the flange to the block, as you can see here, I applied some extra JB Weld around the edges. This is very much a belt and braces approach, but I don't want this to leak. The JB Weld will settle because in the 24 hours that it takes for it to cure, it levels itself out a bit. You may be wondering why I use brass bolts. Well, this is to make it future-proof. Had I have used steel bolts, it really would have been impossible to ever get the flange away from this block again. Time now to make a new backplate. This is the original backplate and it's a bit of a mess. Originally the plate was oversized and it had 3 holes drilled in it. And when I tried to trim it to size, it didn't work because the saw cut went halfway through the second hole. I've not much to say about this job. I just drew round the original component, drilled it and cut it out. This is the pump ram with its 4 O-rings, and these work really well. I showed the fitting of these in a previous episode. With the new backplate in place, a lot neater than the first one, it's time to bolt it all together. I think this is much better than the ugly, clumsy piece of metal originally fitted as a backplate. The JB Weld is still wet. This sequence was recorded just after applying the JB Weld and tightening the 2 brass bolts. I wanted to pipe up the pump in this condition, so I didn't stress out the joint later. I fitted a lock nut to the end of the stud, not that it particularly needed it. It just looks better than the end of the stud sticking out. A quick rotation of the engine tells me that everything is okay. It's 24 hours later, the JB Weld has set and everything's looking good. This is the Injector Water Tap. I've dismantled it for a couple of reasons. One being it was very difficult to turn, and the other one being I needed to pack the stuffing gland. When I poked out the original stuff, it looked like it had come from an Egyptian mummy. Over time there's some limescale deposited by the water in the threads of the valve. So you may be thinking, why not just drop it in the acid bath overnight? Yes, that would definitely remove the limescale, but the patina would disappear. This is supposed to be a sympathetic restoration, so I want the valve to look like it's always looked. Over now to the water tank fittings. I thought it would be a good idea to clean up the threads because I don't want any tightness in these. When I fit them, I do not want them to make the tank leak. I did notice that the elbow that feeds the crankshaft driven pump was quite stiff. But now by running a die down it, the thread is much better, and it will not stress out the tank as I reassemble it. And now it's assembly time. The first thing to do is to refit the newly renovated injector water valve, and once I assembled this using Loctite 542, I put some more 542 on the part that goes into the tank and screwed it into position. You can only see it, you can't appreciate how good this valve feels after I fixed it. And now by the miracle of video, everything is suddenly back together. The water tank is full of water and none of it is leaking out. Time to try the pump. This drain cock, formerly known as the dribbling drain cock, is to bleed the system. I'm not even sure if I waited long enough whether the pump would suck air and self-bleed. The way to use this drain cock is as follows. The engine does not need to be running for this. Connect a silicone rubber pipe to the valve and open it. Close the water bypass valve and suck the water up the pipe, like you would with a siphon. By doing this, you get a column of water all the way down the inlet piping and through the pump. Remove the silicone rubber tubing and run the engine, then this happens. When you see the water, close the bleed valve. Well, this valve's not bad. It's still dribbling a little bit, but it doesn't dribble as much as the one on my big traction engine. And the crankshaft driven pump is really good. It has a very short travel, but pumps a high volume of water. I'm going to see if I can improve the leakability of this plug cock. I removed the plug and cleaned it up with some Brasso. I didn't wipe off the Brasso residue, I just refitted the plug into the barrel and rotated it several times. Then I fitted a new nut and the special washer with the square centre. Take it easy if you're doing this, these are not very strong parts and you can easily shear them off. I've closed the water bypass valve so the pump is pumping against boiler pressure. And it's not bad. Another half a turn made it completely watertight. By watching the water gauge you can clearly see that the pump is filling the boiler. And look at this, I've speeded up the engine and the drain cock is hardly leaking at all. So that's a good result. As usual, I can't help myself. I think just one final tweak will make this valve completely watertight against the boiler pressure. And that's it for this episode. It's good to see the pump working as it should. I'd just like to say stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.